So hello friends, we are designing the steel chimney. So in the previous video we have calculated the forces due to the wind and we have decided our basic dimensions of the chimney. So our problem was we have to design the 54 meter height of the chimney and the cylindrical part diameter was the 2.5 meter and we have provided a flare part of the height 18 meter and diameter was 4 meter at the base. Now this was the summary of forces and we have divided our chimney into the 6 parts of the 9 meter each, and this is the moment at section XX, so 123.112, at the base it was the 4270.20. Now we have to design our chimney. So let us assume the life of chimney is 20 years and minimum thickness will be the D upon 500, that is based on the 6533 part 2, but we have to take minimum thickness as the 6 mm. So this is the minimum thickness. So we have to take this 1 upon 500 of the outside diameter. So outside diameter is the 2.5 meter or 2500 divided by 500. So that will be the 5 mm and it should not be less than 6 mm. So we have to take 6 mm and we have to take the corrosion allowances. So we have taken it 4 mm. So we have assumed our effective thickness 6 mm and but we have take 4 mm thickness for the corrosion allowances, so total will be the 10 mm. But when we calculate for the stresses, maximum stresses due to compression as well as tension, we will take only effective thickness of the chimney. We will not consider this 4 mm, that means 10 mm. Okay, so now first of all we will design our first section, section 11. So height of section is the 9 meter and diameter is the 2.5 meter. And we have already calculated moment at section 11, that is the 123.11 kilometer meter, and effective thickness we have taken 6 mm. So D upon T will be the 417 and this HE upon D height upon diameter 3.6, and from table 3 of IS 6533 part 2 1989 the stresses we have to calculate the compressive stresses. So this is the table 3 of IS 6533, that is the maximum permissible stresses for the circular chimney, that is based on the our ratio HE upon D as well as this is the D upon T ratio. So our ratio is the 417, so we will take interpolation of 400 and 450 and this ratio is less than 20, so our stresses will be in between 70 to 64, so by linear interpolation it is approximately 69 Newton per mm square. So in this way we will calculate our design or permissible compressive stresses, and we have to assume 100% efficiency as we have provided the riveted joints. So let us N1 is 1 and we will multiply N1 1 into 69, so that will be the 69 Newton per mm square, that is the permissible compressive stresses for the section 1, and for the tension we will multiply 0.6 into the 250 the yield stresses 150 Newton per mm square, but we will take the efficiency of joints in tension as 70%, we will multiply 0.7 into 150, so that will be the 105 Newton per mm square. Now we will calculate 3 types of stresses. First self weight, second one is the weight of lining, third one is the wind forces. So stresses due to self weight Fs equals to 0.0785 into H. How this formula is arrived? So for this you have to watch my previous video, first video, that is for the introduction of the steel chimney, not for the design problem. So this is detail is given in the first part, introduction of the steel chimney. So height is the 9 meter, so the stresses due to self weight will be the 0.7065 Newton per mm square. Now stresses due to weight of lining, again it is given in the first part, initial part. This is the third part of our steel chimney, so 0.002 into H upon T, so that will be the 3 Newton per mm square, and stresses due to wind force, that is a plus minus 0.004 into mw upon pi d square into t. So we have put all the values. We have already calculated this in the previous video, and that will be the plus minus 16.59 Newton per mm square. Now we will calculate the maximum compressive stresses as well as maximum tensile stresses. So maximum compressive stresses will be the summation of all three forces. So that will be the 7.89 Newton per mm square, which is less than 69 Newton per mm square. Hence our section is safe. And in the case of the tensile stresses, we will not consider the stresses due to weight of lining, because when tension will act, so weight lining cannot take the tension. So hence we will neglect that, and we will deduct this wind force stresses due to wind force minus stresses due to self weight. So that will be the 3.47 Newton per mm square, that is less than 105 Newton per mm square. Hence our section is safe. Now for the section 2, again it is remains same. Height is 18 meter, diameter 2.5, moment at section 2.2, effective thickness 6 mm, d upon t 417, h upon d 7.2, and from the table 3 it is 69, and this permissible will be the 69, and the permissible tensile stress is 105, and stresses due to the self weight, again we will calculate this 0.085 into h, and h is the 18 meter, so fs is the 1.41 Newton per mm square. Now stresses due to weight of lining, again that will be the 6, and stresses due to wind force, we will put all the values, then we will get it 16.59 Newton per mm square. Now for the maximum compressive stresses will be the 24.01, which is less than 69 Newton per mm square, hence section is safe in compression. And we will check the maximum tensile stresses. So again Fw minus Fs, so 15.18, which is less than 105 Newton per mm square, so hence our section is safe. Now section 3.3, height is the 27, diameter is same, and again we have take same thickness 6 mm. So from the table, that is a 69. In the compression, in tension, it will remain same 105. Stresses due to self weight, that will be the 2.12 Newton per mm square. Now we will calculate the stresses due to weight of lining in the section 3.3. So that will be the 9 Newton per mm square, and stresses due to wind force, that will be the plus minus 36.96 Newton per mm square. Now this is the maximum compressive stresses in the section 3.3, so that will be the 48.08, which is less than 69 Newton per mm square. Now it is near to the 69, and now maximum tensile stresses 34.84, which is less than 105 Newton per mm square, hence our section is safe in the tensile tension. Now for the section 4, again height 36 meter, diameter is remain same, mw is increasing 1912.75 Newton meter, and effective thickness we have increased for the 2 mm. So previously we have taken 6 mm, now in this section we have taken it 8 mm. So d upon t will reduce 313, h upon d 14.4. So from table 3, the permissible compressive stress is the 85, and permissible tensile stress is 105. So stresses due to self weight will be the 2.83, and stresses due to the weight of lining will be the 9 Newton per mm square, and stresses due to the wind force will be the plus minus 48.75 Newton per mm square. Okay. Now maximum compressive stresses will be the 60.53 Newton per mm square, which is less than 85 Newton per mm square, and maximum tensile stresses will be the 45.88 Newton per mm square, which is less than 105 Newton per mm square. Hence our section is safe in the compression as well as in the tension. Okay, now we come to the section 5. Here we have increased again thickness 8 to 10 mm, and then we have calculated all other parameters. Now from table 3 of the IS 6533, so we get the 99 Newton per mm square, and tension again, tension it will be the 105. So this is the figure, shows that different dimensions of this chimney. So this stress is due to self weight will be the 3.53, and this stresses due to weight of lining will be the 9, and stresses due to the wind force will be the plus minus 45.68 Newton per mm square. Now maximum stresses will be the summation of all three stresses due to self weight, due to weight of lining, and due to the wind force, so that will be the 58.21 Newton per mm square, which is less than 99, hence safe. And tensile stresses will be the 42.15, and which is less than 105, hence our section is the safe in the tension. Now for the section 6, we have taken this diameter, average diameter of 3.625. How we have taken it? So we have here the diameter is a 4 meter, here 3.25. So we have taken average of this. So this will be the 3.625. So this is the diameter, and maximum forces we have already calculated, 4270.20 kilonewton meter, and effective thickness here again we have taken it 10 mm, then D upon T 362.5, H upon D 14.9 from table 3, permissible compressive stresses 82, and in the tension it will be the 105, and stresses due to self weight, again we will apply same formula but height will increase, so that is the 54. So Fs will be the 4.24 Newton per mm square. Now stresses due to the weight of lining, that is the 10.8, and stresses due to the wind force, that is the 41.38. Now we will calculate maximum compressive stresses 56.41, which is less than 82, and maximum tensile stresses, that is 37.14, which is less than 105 Newton per mm square. So this is all about the design of chimney from section 11 to section 66. We can divide it, our chimney, into more number of parts, or we can divide it into less number of parts. So you can observe that we have increased the thickness of chimney from top to bottom. We have taken at top, for top 3 elements we have taken it 6 mm, then we have increased in the fourth element 8 mm, then we have increased it to 10 mm for bottom 2 elements. So now this is a summary of all the forces, this is a summary of wind forces, and this is a summary of permissible stresses, and we have taken 666 mm thickness for first 3 elements from the top, and fourth element we have taken 8 mm, and last 2 elements we have taken 10 mm, and for the corrosion allowances we have added 4 mm thickness for each. So we will provide gross thickness at bottom 14 mm, and this is a ratio of D upon T, ratio of H upon D, and compressive stresses from table 3 of IS 6533, and permissible tensile stresses 105, and this is the stresses due to the self weight, stresses due to the weight of lining, stresses due to the wind forces, and at last this is the table shows the maximum compressive stresses and maximum tensile stresses. In all the cases it is same, and I have referred basically two Indian standards, that is the IS 875 Part 3 1987, design loads for building and structures, wind load, that is published by the Bureau of Indian Standard, and IS 6533 1989, design and construction of steel chimney, Part 2 structural aspect, that is the Bureau of Indian Standards. So this is all about the design of the steel chimney. Now if you have any doubt in related to the design of steel chimney, you can ask me through the comment box which is given below the video of this design of steel chimney. So this was the second part, to understand how we will calculate, we can calculate the forces on the chimney. So that is given in the part 1. Thank you.